Right now, 3.7 billion miles from where you are sitting, a dead world is doing something it was never supposed to do. It is moving, not orbiting, not spinning, moving from within. Glaciers of nitrogen are churning across a basin the size of France. Ice volcanoes taller than anything in Japan are pushing frozen slurry up from deep underground. And beneath all of it, locked under a shell of ice in temperatures of negative 230 degrees Celsius, there is water, liquid water, an entire ocean of it sitting in the permanent dark of the most overlooked world in our solar system. For 85 years, every textbook, every model, every assumption we had about Pluto said the same thing. It is a frozen, dead ball of rock and ice, too small to matter, too far away to care about. Then, on July 14th, 2015, a spacecraft the size of a grand piano arrived there after a journey of 9.5 years. And in a single afternoon, it proved almost every one of those assumptions wrong. What it found was not just surprising, it was a complete reversal of what planetary science thought was possible at the edge of our solar system. And there is one discovery buried in that data that changes how we think about where life can exist, not just on Pluto, but anywhere. Stay with me because this story goes much deeper than most people realize. Let's go back to where this story actually begins. January 19th, 2006, Cape Canaveral, Florida. An Atlas V rocket lifts off carrying a spacecraft that weighs just over 1,000 pounds. New Horizons. It was built by the Johns Hopkins Applied Physics Laboratory and the Southwest Research Institute, and it was designed with a single, almost reckless objective: fly to the outermost known planet in our solar system, gather as much data as physically possible during one pass, and then keep going. There would be no orbiting, no second chance. The probe carried 7 scientific instruments, a small amount of hydrazine fuel, and a nuclear power source that generated roughly 200 watts of electricity, about as much as 2 standard light bulbs. That is all it had, and it had to make it last for nearly a decade in the emptiest corridor of the solar system. But what New Horizons lacked in power, it made up for in speed. When the third stage motor cut off 45 minutes after launch, the spacecraft was moving at approximately 36,000 miles per hour relative to Earth. That made it the fastest object ever launched from our planet's surface. 9 hours after liftoff, it had already crossed the orbit of the Moon. The Apollo astronauts needed 3 days to cover that same distance. New Horizons did it before most Americans had gone to bed. 13 months later, it swept past Jupiter, picking up a gravitational slingshot that boosted its speed by another 9,000 miles per hour and shaved 3 full years off the trip to Pluto. Then, the spacecraft went to sleep. For the next 8 years, nearly every system on board was powered down. Once a year, engineers at Mission Control would wake it up, run diagnostics, confirm it was still alive, and send it back into electronic hibernation. Year after year, silence, distance, darkness, and then on December 6th, 2014, they woke it up for good. The approach to Pluto had begun, and what happened next was something nobody at NASA was fully prepared for. For decades, every model of Pluto described the same world: small, cold, geologically dead, a cratered surface that had not changed in billions of years, something like our moon, only smaller, darker, and far less interesting. The expectation was reasonable. Pluto is tiny, 2,370 kilometers across, smaller than Earth's moon. It orbits more than 30 times farther from the sun than we do. Surface temperatures sit around negative 230 degrees Celsius. At that distance, sunlight is roughly 1,000 times dimmer than what we experience here. By every thermodynamic model available, an object that's small should have exhausted whatever internal heat it once had billions of years ago. It should be a frozen solid all the way to its core. So when the first high-resolution images arrived on July 14th, 2015, what appeared on the screens at Johns Hopkins was not what anyone had predicted. Not a cratered wasteland, not a dead rock. What the cameras revealed was a world of startling geological complexity. Smooth plains, towering mountain ranges, and an enormous, bright, heart-shaped feature that would soon become one of the most recognizable images in modern space exploration. The western lobe of that heart, a vast basin now formally named Sputnik Planitia, stretches roughly 1,000 kilometers across. It is filled with nitrogen ice. And on that entire expanse, covering an area comparable to the state of Texas, there is not a single impact crater. Not one. In planetary science, that is an extraordinary statement. It means the surface is young, geologically speaking, being renewed, reshaped, erased, and rebuilt by processes that are still happening now. Published in the journal Nature in 2016, William McKinnon and colleagues on the New Horizons Geology and Geophysics team showed that the nitrogen ice in Sputnik Planitia is organized into enormous polygon-shaped cells, each roughly 10 to 40 kilometers across. These polygons are the visible signature of convection. Warm nitrogen ice rises slowly from below, spreads across the surface, cools, and sinks back down at the margins. The entire basin operates like a massive geological conveyor belt. Think of it as a lava lamp the size of a country, except instead of wax and oil, it is frozen nitrogen churning at a pace measured in centimeters per year. Now stop and sit with that for a second. A world that was supposed to be dead is actively resurfacing itself in 2026. But here's the part of this that stops being abstract and starts being personal. What is driving that convection? Heat. And that heat has to come from somewhere, which means something inside Pluto is still generating energy. Gravitational data from the flyby confirmed that approximately 70% of Pluto's interior is rock, and rock contains radioactive elements, uranium, thorium, potassium, decaying slowly over billions of years, releasing heat into the surrounding material. That heat is not just churning glaciers. According to multiple research teams, it is keeping an entire ocean of liquid water from freezing solid beneath the ice shell. If that ocean exists, and the converging lines of evidence are strong, it means liquid water can persist for billions of years in a place where no one thought it could survive, not close to a star, not warmed by tidal forces from a giant planet, just a small body, far from everything, keeping its own water liquid through radioactive decay alone. We do not yet know exactly what that means for the question of where life can emerge, but the fact that we now need to ask that question about Pluto, about a world 40 times farther from the sun than we are, is itself a fundamental shift in how we draw the boundaries of the habitable universe. And then something happened that almost ended the entire mission before it could deliver any of these answers. 10 days before the flyby, on July 4th, 2015, mission controllers at Johns Hopkins lost contact with New Horizons. At 1:54 p.m. Eastern Time, the signal simply vanished. The spacecraft was 3 billion miles away. A round-trip radio signal at the speed of light took roughly 9 hours. Every instruction, every diagnostic, every correction had to travel across that distance and back. For 81 minutes, there was nothing. The team did not know if the spacecraft was tumbling, damaged, or lost. Then at 3:15 p.m., the backup computer made contact. What had happened was this. The main computer had been simultaneously processing a large block of flyby commands while compressing earlier science data. The dual load overwhelmed the processor. The system, doing exactly what it was designed to do, entered safe mode and switched to the backup. But safe mode meant science operations were suspended. The flyby sequence had not yet been uploaded, and they were 10 days out from the only chance they would ever have. Think about what that engineering process actually looked like from inside the control room. Every command you send takes 4.5 hours to arrive. Every response takes another 4.5 hours to come back. You cannot see what is happening in real time. You are making decisions, writing code, and uploading instructions across a 9-hour feedback loop, knowing that one wrong line could brick the spacecraft permanently. The team worked around the clock. By July 6th, they had diagnosed the problem, confirmed no hardware had failed, and begun uploading the full flyby command sequence to New Horizons. By July 7th, all planned science operations were restored. Alan Stern, the mission's principal investigator, told the press the anomaly would not even change the mission's grade from an A+ to an A. 30 observations were lost during the 3-day recovery, less than 1% of the total. But every single person on that team understood how close they had come to losing everything. If you are the kind of person who wants space stories explained clearly instead of buried under jargon, go ahead and drop a like on this video right now because it genuinely helps this kind of content reach more people who would enjoy it. Now let's go deeper into what New Horizons actually found, because the surface of Pluto is unlike anything else we have ever seen. Let's start with the mountains. The Tenzing Montes and Hillary Montes, named after the first climbers to summit Everest, are ranges made of water ice. But at negative 230 degrees Celsius, water ice does not behave the way you know it. It becomes as rigid and as hard as granite. These are mountains made of ice that acts like rock, rising 3 to 5 kilometers above the surrounding terrain, comparable to the Alps. And the snow that covers their peaks is not frozen water. On Pluto, it snows methane. Bright white deposits of frozen methane gas settle on the dark water ice ridges, creating a landscape that looks eerily similar to snow-capped mountains on Earth, but is built from an entirely different chemistry. Then there is Tartarus Dorsa, east of the heart. There are no mountains here and no plains. Instead, enormous blades of methane ice rise straight out of the ground, hundreds of meters tall, packed tightly together like the teeth of a saw. Scientists believe these structures were carved over millions of years by sublimation, the sun slowly evaporating the ice from specific angles, leaving behind these narrow, towering spines. Now move to the equator. Vast regions stretching thousands of kilometers are stained a deep reddish brown. This is Cthulhu Macula, not iron, not clay, but organic material. High in Pluto's atmosphere, ultraviolet light from the distant sun breaks apart methane molecules. The fragments recombine into complex carbon-rich compounds called tholins, which settle slowly onto the surface like chemical snowfall. Pluto is covered in the building blocks of organic chemistry falling from the sky. And here is where the science goes somewhere genuinely unexpected. A paper published in June 2020 in the journal Nature Geoscience by Carver Beerson, Francis Nimmo, and colleagues at the University of California, Santa Cruz presented evidence that Pluto did not start cold and gradually warm up. The traditional model assumed Pluto formed as a frozen ball of ice and rock, and that radioactive decay slowly melted enough interior ice to create a subsurface ocean over time. But Bierson's team showed the opposite. The surface geology, the pattern of cracks, faults, and ridges, is consistent with a world that has been expanding throughout its entire history. Not compressing first and expanding later, the way a cold start model would predict. Expanding from the beginning. Their conclusion? Pluto was born hot. It formed rapidly, possibly in as little as 30,000 years, from a violent bombardment of icy material that generated so much energy on impact that the interior melted almost immediately. Pluto began its life as a water world, a global ocean hundreds of kilometers deep with no solid surface at all. Only later, as the bombardment stopped and space began to cool the exterior, did an ice shell form on top. But the ocean beneath never fully froze. It is still there. And the ammonia dissolved in it acts as a powerful antifreeze, keeping the water liquid at temperatures that would freeze pure water solid. William McKinnon, one of the mission's lead scientists, described this ocean as a thick, cold, salty syrup. Now let's talk about what is happening right now in 2026. Pluto is moving away from the sun. Its orbit is not a circle. It is a pronounced ellipse, and the dwarf planet is currently drifting into its long winter. Surface temperatures are dropping. The thin atmosphere, already 100,000 times thinner than Earth's, is beginning to collapse. Nitrogen gas that was released from warming ice during Pluto's closer approach to the sun is now refreezing and falling back to the surface as a global nitrogen frost. Within the coming decades, the atmosphere will essentially cease to exist. The sky above Pluto will go from a faint blue haze, captured beautifully by New Horizons in that famous backlit image, to nothing, silence. And then, not for another 100 years or more, as Pluto slowly arcs back toward the sun on its 248-year orbit, the ice will warm, the gases will rise, and the atmosphere will rebuild itself from scratch. Pluto breathes. It inhales an atmosphere, holds it for a few decades, and then exhales it back into frost. And the New Horizons data that revealed all of this is still being analyzed. As recently as 2023, researchers presented new findings at the Lunar and Planetary Science Conference showing evidence of massive landslides on Pluto's surface, large enough to bury entire cities. The spacecraft is now more than 60 astronomical units from the Sun, deeper into the Kuiper Belt than any active probe has ever traveled, still sending data, still functioning, still carrying the only close-up record of a world that will not be visited again in any of our lifetimes. Here is what I want you to take away from all of this. We spent 85 years looking at Pluto through telescopes and seeing a faint, dim point of light. Even the Hubble Space Telescope could barely resolve it into a blurry disk. We built models based on assumptions, cold, dead, unremarkable. And then we sent a machine the size of a piano, powered by less electricity than your kitchen refrigerator uses, across 3 billion miles of empty space, and it shattered every single one of those assumptions in a matter of hours. Pluto is not dead. It has mountains made of ice harder than stone, glaciers that churn themselves young every million years, volcanoes that erupt frozen ammonia, an atmosphere that appears and disappears with the seasons, and beneath it all, a liquid ocean that has persisted since the dwarf planet was born, an ocean that may contain the chemical ingredients for life. One spacecraft, one pass, one afternoon of data collection after 9.5 years of flight, and it rewrote what we thought was possible at the frozen edge of our solar system. No second mission to Pluto is currently approved. No follow-up is scheduled. The data New Horizons gathered in those few hours on July 14th, 2015 may be all we have for decades. One machine, 7 instruments, a nuclear battery, and the single most dramatic revision of a world in the history of planetary exploration. If this story surprised you, subscribe and turn on notifications because we cover stories exactly like this every week. The real science explained clearly, no exaggeration. Drop a comment and tell me what part of this caught you off guard the most, because it helps me decide which stories to research next. And if you know someone who still thinks Pluto is just a boring ball of ice, share this with them. This world deserves better than the silence it has been getting.